Okay, section 8-2, conservation of mechanical energy. Now this section we saw already are the big idea in lab, so I'm just going to highlight those main principles. One, that mechanical energy is kinetic energy plus potential energy, and if you have only conservative forces in an isolated system, mechanical energy is conserved. So conservative forces, we now know what that means, right? Force of gravity, spring force, no friction. And then an isolated system, meaning we don't have any external forces that are, say, giving something a push. And mechanical energy is conserved. That means that at some instant in time, point 2, that sum of mechanical energy will have to equal the same at some other instant in time, point 1. A lot of times we're going from all potential to all kinetic, but sometimes we have a combination of some potential, some kinetic to all kinetic, or somewhere in between. All of those will work. So with that principle in mind, we're now going to put this to the test with a checkpoint. So it says the figure shows 4 situations, 1 in which a stationary block is dropped, and 3 in which the block is allowed to slide down frictionless ramps. Rank the situations according to the kinetic energy and the speed of the block at point B, greatest first. All right, so for this, it's a really challenging one that usually produces a lot of good discussion. So this one, I really want you to write down a response and even pretend to explain it to someone so that you actually go through this process. So please, at this point, pause the video and write that down. Okay, hopefully you've paused. I'm going to keep going, trusting that you have. So we'll see. So first, you have your ranking for part A, ranking the kinetic energy at point B, and then ranking the speed of the block at point B, greatest first. Now, usually what I see on this is some combination of C, where 1, 2, and 3 are faster than 4, D, where it's all of them are the same, or of A, where it's like, okay, the more direct the route, the higher the kinetic energy and the faster it's going. So let's take a look at the answer. It's D for both. It's all the same. And this is because it mentions that they're frictionless ramps. Because they're frictionless, then there's no non-conservative forces. And so the only thing we care about is the difference in height, the potential energy of each of them. Since they're all going through the same net difference in height, then they all have the same kinetic energy at point B and also the same speed at point B. Now, a few differences, right? For this fourth one, it does reach a higher speed when it goes below point B, but then it slows back down to the same speed as the rest when it comes back to B. Other considerations, these 4 options do not have the same time to reach point B, right? Point A is the most direct route versus the others have a lower acceleration, and so it'll take them more time to catch up to that same speed. But in the end, they will all reach the same speed. And we can prove that because of this conservation of mechanical energy idea. So I hope if you're uncomfortable with that you keep wrestling with it, ask questions in the discussion section, and let's keep going with these ideas because this is a really crucial one. So dig into it. All right, good luck.